Welcome back to the video lecture series for Introduction to the Art of Programming using Scala. We continue looking at our expression parsing and parsing it to a tree. We've decided that we would like to be able to parse an expression like this to a tree, and in the previous video we added support for variables into the code. Without the variables, there really isn't much point in being able to parse to a tree, but once you have the variables, it's reasonable to have a situation where you want to evaluate these multiple times. Indeed, one of the larger software projects I've worked on had this type of thing happen, and you would be in a loop where you'd want to evaluate a formula like this 1,000,000 times. And so it really did help if it was faster, and having it parse to the string is not fast enough. So if we want to change our code here to make it so that it actually works with a tree, first thing we're going to do is, in addition to having the object, we're going to create a class. The class is going to be used because we need to have objects that represent that expression. And so when we create an expression parser, we will pass it our expression, which is a string. Okay. Now this code that right here was just inside of an eval, and technically this code could actually stay inside of the eval here, but what I want to do, since I don't feel like duplicating the code, is I want to paste it up here, and I want eval to not return, actually I'm going to change the name so it's not called eval, now it's called parse. How about we call it parse to tree to make it explicit? And what we pass into the parse is the expression that we want to parse, and it is supposed to return, well, something that can represent a tree. Following what we've done previously, we're going to create a type called node. We don't have it yet, but we'll want to create one. Also, I need to put some data in here, and as with all the previous trees we've done before, we're going to have a root, which is of type node, and the way this starts off, we're going to call parse to tree on our expression that was passed in, this is in keyword val, so the root is set equal to the results of parse to tree. To make this so it's a little bit happier, we'll go ahead and declare our tree type, our node type. Right now I'm going to keep this simple. Turns out there are reasons why it would be nice to put this inside of the expression parser. Actually, let's go ahead and do that. The nodes don't actually have to know what instance of the class they're inside of, so in a situation like that, it's better just to go ahead and put them down in the object. Now we're going to make use of inheritance here, so I'm going to create my trait called node, and of course that makes this happy. What can we do with a node? Well, the nodes that we have are things like plus would be a node, times would be a node, 4 would be a node, 3 would be a node. Every one of the nodes in the tree is going to be a node following this type, and we're going to create multiple subtypes of this. But there's one method in particular they all need to be able to do, and that is that they all need to be evaluated. And following kind of the Scala style for how we do this, I want to say that we're going to have an apply method which takes a map of string to double that we'll call vars, and it returns a double. So all of our node types will have this inside of it. What kind of node types do we have? Well, we need to have a class for, how about a number node? And so like the value 3 needs to be represented by a number node. When we create one, it will have a double inside of it, and it needs to be a subtype of node for this to work. So what happens when you call apply on a number node? Well, it pretty much ignores the map that gets passed in and simply returns the value. Similar to the number node is going to be a variable node. So here in our tree, this x here, so the number nodes would be the 4, the 3, and the 5. This x is going to be a variable node. We don't pass in the value, we pass in the name, which is a string, and this should return vars sub name. So it should look up that name in the map and return the value of that. So we've made a node type for all of our leaves here. We have not made a node type for these. Now, in many languages, I would wind up creating a separate subtype for every one of the different operations we have. So I'd have an add node, a subtract node, a multiply node. But in Scala, I'm not going to do it that way. I'm going to create a binary operator node, and it's going to take 3 values inside of here. So I guess I'll start with the operator. The operator is a function that takes a double and returns a double. That's basically what plus, minus, multiply, divide are when we're operating on doubles. Plus takes 2 doubles and gives you back a double. I also want to have a left, which is a node, and a right, which is a node. And once again, extends node. What does the apply method look like for this? Well, we need to apply this operator to the left and the right, but this was not happy because left is a node and op takes doubles. So we actually have to call the apply method on left and call the apply method on right. And remember, the apply method is simply called by putting parentheses after it. So we treat left and right as functions that calls their apply methods, and then we pass the results of those into this operator. So that sets up the types that we have inside of here. Now we'll have to come back in the next video and modify the code so that it actually returns the values that are of type node.